This angles proof reference sheet should look quite familiar to you. This is very similar to the segments proof reference sheet we had. If you notice right here at the top, we've got the properties of equality. We already talked about all of these. You use them hopefully on your test. A lot of these are when you add the same thing to both sides. That would be over here, that addition property, or subtract the same thing from both sides, the subtraction property. These ones we should be getting very good at. Now we've also got the properties of congruence over here. These are from our last packet, symmetric, reflexive, transitive. Hopefully with all the practice we've been doing on those, you should be getting good at them. That's why they're just listed at the top here. You got to know what these mean now. Now let's go down and look at some stuff that might be a little new. Now the first one is definition of congruence. And so remember that this little m here means the measure of angle A. So it's saying if the measure of angle A equals the measure of angle B. And remember that we measure angles in degrees. So if they have the same degree measure, then they are congruent. So notice what happened. We changed from here we had an equal sign, here we have a congruent sign. The definition of congruence, same as before, let us switch from equal to congruent. So that's what this arrow right here means. Let's us switch both ways, from equal to congruent or from congruent to equal. And right away while we're looking at this, I want to make a note going down to this arrow, and saying that this lets us switch both ways. So what that means is for the definition of complementary angles, if we know this, if we know two angles are complementary, then we can conclude, oh, their sum must be 90. Similarly, if we know this, if we know their sum is 90, we can go the other way and say, oh, they must be complementary then. So it's a really useful tool to know that we can use these either way. That's what those arrows mean. Now we've got definition of angle bisector. And we've said millions of times in class, an angle bisector divides an angle into two equal parts. So we're going to know the two parts are equal. And for perpendicular, we're going to know that we get right angles. What do we need to look for? We need to, let's not use the keyboard. Let's use this. Look for what? When we're looking for right angles, in a picture, we want to look for a box. Something like that. And if we see a right angle, then the definition of a right angle means that it is 90 degrees. So we're just kind of going through these. Most of these we should know what they mean. We don't have to fill much in. We just have to make sure that we understand all of these. So let's go down. Before we had the angle addition or the segment addition postulate, now we have the angle addition postulate. So I'm going to zoom in here so I can get this right. In the angle addition postulate, it says the measure of angle ABD. So I'm going to put that in one color. There's ABD plus the measure of angle DBC. There's angle DBC. Those are the two parts, the two adjacent angles. And if I add those two angles, I get the measure. There should be an M here in front of that. Let's actually fix that. So there should be a little M right there. Measure of angle ABC. And let's put that in a different color. I'll put that one in green. And so this is what the angle addition postulate means. This is how we can match it up to the picture. But the way we mostly remember this is we say that part plus part equals whole. So if we have a picture like this, and this is the one thing, once again, in this section, now that we're doing proofs with angles, we have a little bit of different reasons, but this is the only thing that is going to come from the picture. Everything else is going to come from previous steps or from the given or et cetera, et cetera. The angle addition postulate here is going to be coming straight from the picture. So we have to look for a picture like this where we have two smaller angles inside of a bigger angle. So we have a part plus a part equaling a whole. Let's keep going on. We finally have some theorems. We hadn't had anything yet that we called a theorem. So let's look at these theorems. So the first one is vertical angles. So let's help ourselves to remember that. Vertical angles, so our picture, let's make it nice and small so we can not take up too much space. Vertical angles will make an X, like angle 1 and angle 2. So if two angles are vertical, then they are congruent. So that would mean angle 1 is congruent to angle 2. So if we have two angles that make an X, like vertical angles, then we know they are congruent. Up above, notice this next one, the complement theorem says if we have a right angle, then the angles are complementary. If two angles make a right angle, then they're complementary. If I scroll up, I had definition of complementary. Let me go from complementary to their sum is 90. But this lets me go from the picture to saying that they're complementary. If I know they form a right angle, then they're going to be complementary. And similarly, let's just draw pictures to kind of help us know what to be on the lookout for. So here, if I have two angles like this, and they form a right angle, that means they must be complementary. Supplement theorem says if two angles form a linear pair. So what's a linear pair look like? A linear pair, remember, it's two angles that make a what? That make a line. That's why I started with a line. And then I'll draw that to show that I've got two angles here. So if these two angles make a line, then they are supplementary because they add up to 180. All right, now the congruent complements theorem and the congruent supplements theorem, these are sort of like the transitive property. Let's talk about why. So if A is complementary to B and C is complementary to B. So what's going on here? We've got both of these angles, A and B, complementary to the same thing. So what does it mean to be complementary to something? It means that they add up to 90. So if A is complementary to B, let's say B is 30. If B is 30 and A is complementary to B, then A 30 degrees, that is, because we always measure angles in degrees. B is 30 degrees, A is complementary to it, A has to be 60 degrees. If C is also complementary to B, well, B is still 30 degrees, so guess what? C also has to be 60 degrees. So this is sort of like the, like I said, sort of like the transitive property, where if we know two things are equal to the same third thing, then those two things are going to be equal to each other. I hope you can imagine in your head right now me making the hand motions that I make as I stand in front of you every day and say, if this thing over here is equal to this thing in the middle, and this thing over here is also equal to this thing in the middle, then they're equal to each other. It's the same thing for complementary. If both of these two things are complementary to B, then they're equal to each other. Now, supplementary goes the same way. So if A is supplementary to B, C is also supplementary to B, so they're both supplementary to the same thing. So what does that really mean? That means that supplementary means adds up to 180. So once again, if B is 30, now A would have to be 150 to make those supplementary. And if B is 30, guess what? C is still supplementary to it, so C has to be 150 degrees as well. So these are important. There's the conclusion there. There's the conclusion there. So not anything we didn't already know. A lot of stuff we already knew going on here. It's just reminding ourselves what all these words mean. And this chart is very important. You're going to want to keep this chart with you while you're working on proofs. For today, though, for your homework today, what I want you to do is flip this page, and on the back are a bunch of statements, and then you've got a bank of reasons. I want you to match up what reason goes with each statement. Good luck.